Alright, this is a quick video where I'm going to explain how to set up the YuMi robot to work with Machina and how to make the system be able to control both arms at the same time and input and receive data in real time about the state of the system. As of right now, because Machina is still very much in development, it involves some hacking and quite some manual setup, but hopefully in the future this will be more streamlined and much better. So let's get to this. So the first thing that I would like to note here is that I have a Robot Studio open, and it's got a YuMi, a simple YuMi with both arms, and nothing special about it. Right now this is just out of the box a Robot Studio model. What I'm going to do is most of the setup that I'm going to try to do, I'm going to do it with the virtual pendant just in case. Some things are much easier to do directly in Robot Studio, but I'm going to do them in the Flex pendant for the sake of also trying to model how this would be in the real world. So I'm going to open here, I'm going to open a Flex pendant, which I'm going to bring here, and I'm going to open the production window, and you can see that here we have the two arms, and right now there's no program involved here. So we're gonna start here, and what we're gonna do first is we're gonna get one arm working, then we're gonna add the second arm. We're gonna have them both working at the same time, and then we will add the real-time monitoring after that. So what I'm going to do now is I'm going to open a Machina bridge, right? And then I'm going to configure this bridge to connect to the right arm. Right now, one bridge cannot control both arms, or two robots for the same matter, so we will need to have two bridges in parallel and talk to each other for talking to each one of the arms independently. So for example, assuming this one is going to be the right arm, I'm going to change the name here. I'm going to call this right arm, and I will have to connect manually. Alright, so I'm going to choose user here. This is the local IP of my computer. But if I was physically connected to the robot, this would be 192.125, so 192.168.125.1 probably. And then the port for this initial arm, I'm going to keep it at 700. You can click here a button where you can download the modules that will need to be installed need to be running on the robot. And so I just downloaded this file here, which has the modules for the right arm. I'm going to extract them here into a folder, and yep. And now I have a folder on my desktop with all the modules necessary for the driver and the monitor. So I'm going to load those on. I'm going to load one of those on the Flex pendant. So to the Flex pendant, first I'm going to deactivate the left arm because I'm going to start simple with the right arm. And here for the right arm in the production window, I'm going to load a program, and then I'm actually going to move these guys to my C drive at the root because it's going to make things a bit easier. Let me do that. Alright, so I moved the folder here to the drive C and to the Machina modus right, and I'm going to load the driver. The driver is the basic module, the basic program that is the one that we communicate with. The monitor is for the real-time updates. We will get to that a bit later. So I'm going to load this program, and you can see that if I go to main and I run the program, I get this message saying that the Machina initialized, that is listening. So right now, because we can see that this IP and this port match this IP and this port, if I connect, then I will be able to see Machina confirming that somebody is connected, and the bridge here giving me information about the state. So I'm going to start playing with the robot a little bit. I'm going to say I'm going to move the robot a little bit up in Z, and the robot is moving in Z, right? I'm going to do the opposite. I'm going to move it like negative Y. Alright, and that's negative Y. Alright, and then for the YuMi in particular, if we go here to the right arm and we do linear jog, we can see that these are the XYZ of the tip, but also 7 robotic arms with 7 degrees of freedom have this extra parameter, which is called the arm angle. The arm angle is basically a relation between the rotations of the joints around the 7th angle measured in degrees. It's a bit of a strange measure, but sufficient to say that when you move the robot around in Cartesian space, what the robot, the controller by default, tries to do is to go and move in XYZ with the orientation that you told it, trying to maintain the same arm angle value. So for example, if I move 100 units in X, the arm angle is going to up. That is far too much. Okay, so this is a good opportunity perhaps to like try out restarting. So you can see that everything stopped here, everything crashed, it doesn't work. So when this happens, the best thing to do is just to disconnect and then go move the program to the main program and then start again. We're waiting, and here we can connect, and now we're back. All right, we're back online. All right, so now let me try instead to move back in Z X minus 100. And as I move, you can see that this value kind of stays constant, but if there was no kinematic solution, if the robot could not reach the position that I told to with this arm angle, then it would vary that arm angle to find a solution to that target. All right? What does that mean? That means that unless we care a lot about it, we don't really need to specify the angle of the elbow, right? The angle of the arm angle. But if we wanted to, for whatever reason, we can. We can do that with Machina by using the arm angle action. What this does is it sets with which arm angle value I want to reach my next movement. All right. So for example, if right now we can see that the arm angle is 155, let's say that the next time I move, I want the arm angle to end with a value of 150, right? So I can send that, and I don't. Okay, let me check what's going on. Oh yeah, I forgot that I had disabled the relative version of this action, so it has to be arm angle 2. All right, so next, if I say that, then the next movement is going to end with arm angle at 150. So for example, let's say that I move 50 units in the X direction. We can see how the arm angle is slowly rotating, and by the end of the motion, it will get close to that. If I just wanted to move the angle for whatever reason, I could say, well, I want to end in 140, but I don't want the position of the hand to go anywhere. So what I can say is well, I'm going to set that value and I'm going to move nowhere. And then the elbow adjusts right up. The elbow adjusts, but the tip of the hand doesn't go anywhere. All right? All right. Another difference with the YuMi, because each arm has 7 axes, 7 joints, is how the behavior of controlling those 7 joints happens in Machina. All right. So for example, I'm going to go here now, and I'm going to go to joint jog, and I can see that I have the values of the 7 axes, the 7 joints of the robot. All right. As we know, with Machina, you can control the values of 6 axes, right? So for example, let's say that I want to set the values for the first 6 axes here. I'm going to set these values to roughly something similar to what we have right now. So 55, minus 25, 0, 70, 45, minus 80. All right, those are the first 6 axes. All right, if I do this, then you can see that very slowly, and The lag is just my computer recording the screen. But you can see that very slowly the first 6 axes go into the value that we just specified, okay? Naturally, it will feel logical that if I just added like a 7th number here, so for example, minus 90, then I would be able to control the 7 axes independently. But that functionality is still not available in Machina. Hopefully it will be sometime soon. So a workaround to that is by using the ABB internal representation of how ABB basically deals with that 7th axis. And ABB deals with that 7th axis by considering it the first external axis of the robot, right? So in a very similar fashion to what we did with the elbow, what I can say is, well, if I want to control also the value of the 7th axis of this robot, I can control it by changing the value of the first external axis of the robot, all right? So I can say, I want to set the value of the external axis to, and this is going to be the first external axis of the robot, that's the 7th axis in a YuMi. Then I'm going to set the value of, for example, minus 90. And this is particular also to the YuMi situation. I want to be specific and say that I want the external axis of this joint to be changed. ABB treats external axis for a target motion and for a joint motion separately, all right? So if we didn't have this, then we would set, it would be a mess. It would not work for YuMis, all right? So this is very important to remember if we want to hard code the value of the axis, right? So I specify that, nothing happens because it goes into the next motion. And now if I say, well, now I am going to set the axis to the values that I had before, now you can see that now is when the 7th axis effectively changes and gets that value, all right? So long story short, if you want to set the values of the 7th axis to the YuMi, you have to do it, as of this recording, you have to do it by first setting the value of the first external axis in joint mode, and then right afterwards setting the value of the 6 regular axis. All right? And I think with this we have covered all the basics of what's different in a YuMi arm than any other regular 6-axis industrial robot. All right? So we're going to move on into how to set Machina to control both arms at the same time and to monitor the progress of that. All right, in order to control both arms, we will have to install 2 drivers on each one of the robots, on each one of the arms, right? So as you saw before, here I'm going to disconnect from my bridge. I'm going to stop the execution of the driver, and as you can see from before, the robot has 2 arms, and I can switch between them, the left and the right arm. And the left arm we did disable here on the task. I'm going to enable the task for the left arm, and you're going to see that I did disable it because if I run it, it says that the left arm has nothing, so it can't go on. All right, so we need to load here another driver so that we can talk to the left arm, but we will not be able to use the same driver that we use for this bridge. If you remember, I specifically opened this bridge for the right arm, and that's because since we're basically what we're doing is we are creating a small server in each one of the arms, those servers need to have different addresses. They can have the same IP, but at least they need to have different ports. So what I'm going to do is I'm going to say, well, I'm going to go to my, where was that? I'm going to go to my bridge app, all right? And I'm going to open another bridge app, all right? So I'm going to have 2. This is going to be the right arm, and this is going to be the left arm. I'm going to write it here, left arm, all right? And what I'm going to do here is I'm going to give it another port number. The port number, it's nice if it's like farther away from the original one, so I'm going to call this 7100, all right? I I'm going to download my drivers, and then I'm going to say these are going to be the modules of the left, which are going to go to hard drive Z. And then I'm going to extract that, and here on the left arm I can now go to my C drive, and there's this new folder that I just downloaded, and it's got the driver that I'm going to load on the left arm. And now I'm going to restart both of them. I'm going to restart both programs by moving the program pointer to the main position, and then I'm going to start them both. As I do, you can see that both the right arm and the left arm initialized, and each one of them with the same IP but a different port number. All right, that is great. Okay, so what I'm going to do is I'm going to try to connect back to the right arm on 7000, and we can probably see here that everything went well. All right, and now on my left arm I'm going to connect to 7100. I'm going to connect, something happens, yep, I connected, everything works great. All right, well, let's see if I can talk to the two arms independently. All right, again, right now, as of this writing, we still have to do two independent bridges. Hopefully at some point there will be one bridge that can control the several arms or several robots for the same matter. All right, so here for the right arm, I'm going to set the speed to something very slow, like speed to 5, and then I'm going to move the robot like I don't know, 100 units in the Z direction. I'm going to copy this, I'm going to paste it in the left arm as well, and then I'm going to execute this, and you can see that the robot starts moving, and I'm going to execute this for the left arm, and it's very hard to notice, and my recording is getting blocked, but I think I can see, yeah, everything is super blocked, but I trust that this is happening. Let me pause, and yeah, exactly, my computer cannot deal with recording this video, recording and having 3 monitors. So, but you can see that the action was completed with this debug logs that I have here, and also this one was also completed. So you can trust me that both arms moved at the same time. All right. Also, because we're using 2 bridges, there's no coordination between those motions. So you saw that I basically just did this one, and then very fast I did this other one. So if you wanted to coordinate those, you would have to, like, right now Machina doesn't have that possibility, but hopefully it will at some point in the future. But basically, whatever you are using to talk to the bridges, then you can just send those 2 commands at the same time, and roughly it will happen all simultaneously. We can see that I sent an action that took the robot somewhere out of reach, so everything has stopped here. So what I can do is I can stop, set the program pointer to main, and run everything again. All right, and then here I can just disconnect and connect again. This got connected, and same thing for the right arm, and everything got connected. All right. All right, cool. So let's move on into how to set the robot up to be able to track in real time the motion of the robot. All right? All right. All right. Just like before, we did manually install 2 servers, one on each arm, so that we could talk to each one of the arms independently. In order to be able to track the motion of the robot in real time, what we need to do is we need to create 2 other tasks, so 2 other small programs, right? And then install a different server, a server that we're going to call the monitor, so that not only can we talk to the robot with one server, but we can also listen from the robot with the monitor server. All right. In order to do that, first we need to create 2 new tasks. So imagine as creating like empty programs that we will fill in with our modules. All right. So the way to do that is by going here in the Flex Pendant and going to Control Panel. And if you hit configuration, you'll see that it tells you that you cannot do anything because we are in automatic mode. The YuMi is usually by default in automatic mode. So what I'm going to do here on the settings, I'm going to set this to manual, and you're going to see that the motors went off, etc. And now in configuration, I have several things. This is where I can change all the internal configuration of the robot. I will go to controller, and in controller, we will have tasks. So if I double tap, you see that the 2 tasks we have right now are each one of the arms. So we're going to add 2 new tasks. First, we're going to add a task to monitor the right arm. I'm going to call this T-Rob R monitor, mon. This doesn't really matter, but it's just for the sake of consistency with the name of the other. We're going to have no task on the foreground. The type is going to be normal so that we can control it and ourselves. And the mechanical unit group that this is going to be associated is going to be the right robot. We want to track the movement of the right robot. All right. So that's it. We start this. We don't want it to restart because we also want to create another task for the left arm. All right. So I'm going to add another task. This is going to be T, Rob, L, and then Mon. All right. It is also going to have no task on the foreground. This is going to be normal. And the mechanical group in this case is going to be the left arm. All right. Now that we did set up the 2 extra tasks for each arm, we can restart the robot. All right. And the controller is restarting. Everything is restarting. So I will have in Robot Studio, I will have to open a new Flex Pendant. Also, if you're a Robot Studio user, you will notice that now here we have, I have a typo here, it doesn't really matter. Now we have here the 2 conventional motion tasks and these other ones that are going to be for supervision. All right. So if I go to production window, you can see that I can now see the 4 tasks. So I'm going to use the same files that I downloaded with the bridges before because they already have the ports correctly configured. So here for the right monitor, I'm going to go to Z, to my Z drive, which is where I downloaded, Machina modules right, and this time I'm going to choose the monitor program. All right. Also for the left one, I'm going to do the same, but I'm going to go to the modules on the left and this monitor. What is the difference between the servers? They're identical, it's just that they have the port number is different between them. Okay. So I'm going to take everything and send it to the main. All right. Yep. Program pointer to main, and I'm going to start all those tasks. You can see that now the monitor initializes and is waiting, the other monitor is also waiting, and also the regular tasks are waiting for someone. Okay? All right, so let me go back to the right arm. Okay? If I now connect with the right arm, what we can see is that I connect, but all of a sudden I also have this stream of messages. They're really hard to read, they have a lot of information, but if you are connecting to the bridge through some other platform, processing, Dynamo, Grasshopper, JavaScript, Python, you will get a very nice JSON object with all the data coming in this format. All right. Here in the bridge, it's not great to see. I will have to probably add some kind of like real-time something here. Anyway, that will happen sometime. But my right arm is now being it's listened to me, but it's also giving me information back. So what I'm going to do is I'm going to move the right arm, but we're going to notice how the values of the TCP X, Y, Z are going to also change. I'm going to move the arm a little bit up. So for example, move 0, 0, and 50 units in the Z direction. And we're going to notice how the Z value is changing, right? And how it doesn't, now that it reached position, it's not changing anymore, all right? Also, if we go back, we will see the value of all the joints here as well. All right, so let's connect with the left arm. If I still have the same port number, that is great. I'm going to connect with this arm, and it's probably not going to connect, okay? As of the writing this video, I'm having a weird problem where if I have a lot of messages very fast coming from one arm, that I don't know if the thread is too intense or what is going on, but it doesn't allow connection from the other arm, all right? I need to figure that out. So if that's the case, but I don't know if it's a problem with Robot Studio, which is usually way, it lags a lot, way more than a regular controller. I don't know if you do this on a physical robot, if it will improve in any case. So I don't have a command to change the rate at which these updates happen, right? But I have a hack. All right. So if you write the following text, the following byte message, you will lower very strongly the rate at which this update refreshes. All right. So for example, and I'm going to pull this up so that you can see that in action. If I write this custom code and I write 103 and the rate at which I want, for example, 5 seconds, semicolon, I close double quotes, and then I also close the statement, you can see that if I do this, I get a message here. Yeah, there's an error. That's because the other socket was trying to connect. All right. So I'm going to stop everything. I'm going to disconnect. I'm going to reconnect again. All right. I'm going to set everything to the beginning, and I'm going to reconnect. But you can see that now, if I connect with this guy, you can see that the rate of streaming is at 5 seconds. Is what I did set before, because this value is persistent. Okay. Because it's updating very slowly, now it's going to give me room for the left arm to connect. So I'm going to connect with the left arm, and you can see that it connected immediately. And both arms are now receiving updates in real time from the same robot, right? I can up the rate again by doing the following, all right? And if I make it this, is going to give me 10 updates per second. So if I do that, you can see that I get 10 updates per second on this arm, but it's also going to broadcast to the other arm. All right. So let's see if that works. I think my computer is going to blow up about what I'm going to do right now, but if I say move a little, this is the right arm, this can go up, and this is going to go down. So all right, so you can see how both are updating. This one is going down, this guy is going up. It's lagging a little bit. I don't know if it's my computer, if it's if with a real robot this will improve, but both have moved. All right, so that's it. A lot of work to be done yet. Let me put this at 1 second and clean this. And you see, this was set to 1 second here. I'm going to clean this. Yeah, so everything is much quieter now. So yeah, sorry for the mess, but the YuMi is definitely a very, very specific situation within robotics. So to make this work right now, it involves a lot of hacking and manual setup. Hopefully, with some more development, I will be able to streamline this process a bit better. All right? Thank you for your attention.